This video is subtopic 2.1, the atom. In English, we get our word from the Greek, atomos, meaning indivisible. Just to remind you, this is the first of 3 subtopics in IB chemistry about atomic structure. We all know that the atom is made of 3 things: protons, neutrons, and electrons. The protons and neutrons are located in the nucleus of the atom, at the center, while the electrons orbit around the nucleus. This is all we have to know about protons, neutrons, and electrons. The proton and neutron have the same mass, which we just label 1 with no units, and the electron has a far smaller mass that we often ignore for practical purposes. The proton has a +1 charge and the electron has a -1 charge. Since atoms are assumed to be neutral, that is, there's just as many electrons as there are protons, we can specify any atom with 2 numbers, written as capital A and Z. A is the mass number, which is equal to the total number of protons and neutrons together, while Z is the atomic number and is equal to just the number of protons. Of course, every element also has a symbol. The element pictured here is helium. It has 2 protons and 2 neutrons, and of course 2 electrons, because again we assume all atoms to be neutral. So what atom is this? It's beryllium, with 4 protons and 4 neutrons and 4 electrons, because again we assume all atoms are neutral. How about this atom? This is what we call carbon-14. If we take the same atom and get rid of what we might think of as extra neutrons, we have carbon-12, which you might think of as normal carbon. Actually, both atoms here are equally truly called carbon, but they are isotopes of each other. Which just notice how they have the same name and symbol and even the same atomic number Z. So in fact, when I refer to these as carbon-14 and carbon-12, notice I don't need to specify the atomic number. So what does isotope mean? Well, iso means same and tope means place. Same place where, you might ask? Why? The same place on the periodic table. Carbon-14 and carbon-12 both belong in the square for element 6. There's many other isotopes on the periodic table, such as lithium-3 and 4, cobalt-59 and 60, and uranium-235 and 238. Carbon-12 has an extra honor in that chemists use it as a reference to refer to the mass of all other atoms and molecules. Ar, the relative atomic mass, is equal to 1/12 of the mass of carbon-12, while the mass of molecules is often stated in Mr, the relative molecular mass, which works the same way. Carbon-14 is an example of a radioisotope. That is, it's radioactive and has a half-life of about 6,000 years. A half-life is the time it takes for 1/2 of a sample of carbon-14 to radioactively decay. Notice that after every half-life interval, another half of the remaining sample will decay. Iodine-131 has a much shorter half-life of only 8 days, whereas cobalt-60 has a half-life of about 2,000 days, somewhere in between. All 3 of these specific radioisotopes have uses in modern science. Carbon-14 is used for dating organic artifacts, while cobalt-60 is used for radiotherapy to treat cancers that are surgically inoperable. And iodine-131 is used as a tracer in medical research. We can use it to follow where certain chemicals are moving in the body, where certain chemicals move to in the body. So far, we've learned about atoms and isotopes, and I should mention ions. An ion is anything that has a positive or negative charge. An ion with a positive charge is called a cation, and ions with a negative charge are referred to as anions. Recall also that we can specify any atom with 2 numbers, the mass number and the atomic number, while the symbol is a short version of the chemical name. So let's apply what we've learned so far. This is helium-4 with 2 protons, 2 neutrons, and 2 electrons. Because it's neutral, we call it an atom. Here is hydrogen-2 with 1 proton, 1 neutron, and 1 electron. This is an isotope of helium. Let's try one a little different. If we have 11 protons and 11 neutrons and 10 electrons, what do we have? Obviously a mass number of 22 and an atomic number of 11, which is sodium. But we have a 1 plus charge because we have 1 less negative electron than the 11 positive protons. This makes this species a cation. Finally, if we have 8 protons, 8 neutrons, and 10 electrons, we have oxygen 16, 2 minus, because now we have 2 more negative electrons than the 8 positive protons, and we have an anion. That's it. Thank you for watching.